Today we're going to learn about scatter plots. A scatter plot is a name for data that is put onto a coordinate grid or a graph. And there'll be several data points, and what we want to do with a scatter plot is we want to look at the data points and see if we can make any predictions, see if we can make any associations. So how do we construct a scatter plot? Well, to construct a scatter plot, simply graph all of the ordered pairs. So we've got this baby alligator. We've got data of how old the alligator is and how much he weighed at certain weeks. So the number of weeks would be on the x-axis because it's independent, and the weight we're going to put on the y-axis because it is dependent. The weight depends on the number of weeks. So we have our graph set up and ready to go. Now we're just going to plot the points. So at 0, so at birth, the alligator weighed 6 pounds. After 9 weeks, it was 8.6. Now you should notice that these are going to be there's some estimations that are happening. When we're trying to estimate something like 8.6, we may not get it exact, but that's okay. When dealing with scatter plots and graphing coordinate pairs, there is going to be some estimation involved. The third data point would be after 18 weeks, it was 10 pounds, so somewhere in that neighborhood. After 27 weeks, it was 13.6, so maybe somewhere right about there. 34 weeks, we were at 15. So something like that. 43, 17.2. So maybe right about there. And then after 49 weeks, the baby alligator weighed almost 20 pounds. So there we have a scatter plot. We have simply taken all our ordered pairs and put them on the graph. Now, what can we do with the scatter plot? Well, one of the things that we're going to do is we're going to look at the types of associations that may be there. So we can analyze the shape of the distribution of a scatter plot to investigate patterns of association. So if you notice here, when all the data points are grouped where there is an upward trend, we call that a positive association. It looks like they're all kind of trending that way. When we have a negative association, that means all our dots seem to be in a downward trend. They all seem to be trending that way. And then no association means there's no visible pattern at all. So if we were to look at a scatter plot, we would want to be able to see if there's any kind of association. Okay? So notice with a positive association, both the x and the y are increasing. And with the negative association, only the x is increasing, but the y is decreasing. So keep that in mind. Another type of association would be linear or nonlinear. If the dots seem to be close to a straight line, we would call that linear. And as we learned early in the year, if there's a curve to the line, that would be a nonlinear association. So what I want for you to do is take a look at this graph. This is actually the graph of the baby alligator's weight over time. What kind of association would we say this is? That's correct, Maddie. Good job. This is a positive association. We have what appears to be a trend going upward. As the weeks increase, so does the weight. And we could also say that this is a linear association. Now, the next thing we're going to do with scatter plots is we're going to come up with a line of best fit. So we want to draw a straight line that fits the data, and we want about half the point to be above the line. Okay, so that's one key, about half the points above the line. And we want about half the points to be below the line, but what's really important is most of the points need to be close to the line. So if I was going to draw a line of best fit for this data, it would probably look something like that. Notice we have 5 points below, and it looks like 6 points above. Well, I guess technically, if we include this one down here, we do have 6 below. But notice they said that most of the points are close to the line. There's no way that we can make this point down here get close to our line of best fit. Now, what we have done with this line of best fit is we've identified the trend, and we can hopefully use that line to make some predictions. Now, what are some ways that you could use a line of best fit? Well, let's take a look at this example. Here we have some data that's already been graphed and a line of best fit that's already been drawn for us. And what we can do with this line of best fit is we can come up with an equation. All right, and then once you have an equation for a set of data, there's all kinds of things you can do. All right, so let's take a look at this. How can I come up with an equation for this line? Well, what I want to do is I want to find 2 points that the ordered pair is very clear. And I would say this one works, right? This would be the point 9, 275. So I've got 9, 275. And then another one that looks to be very usable would be this point here. So now notice I am using the actual line. No longer am I looking at the points that were plotted originally. So I'm using the line. And this looks like it would be the point 3, 150. So I've got 3, 150. So what do I do with the 2 points from this line? Well, there's several things that we can do. You can use the slope formula, which would be y2 minus y1 over x2 minus x1. Or basically, if you remember, what I said was just put them into a table. So if I have 3, 150 and 9, 275, okay, make a table. This is x, this is y. What is the change in y? Well, the change in y is from 150 up to 275. So it looks like the change in y is 125. And the change in x is from 3 up to 9. And so that's going to be a change in 6. So the change in x is 6. So we have a slope now of this line, 125 over 6, which is approximately 20.83. So if we were going to do a slope intercept, y equals mx plus b, the 2 things that we need are the m, the slope, and the y-intercept. Well, here is m. We have found m. How do I find b? Well, with this one, we can estimate. It looks like the line is going to cross the y-axis right about here, which is probably in the neighborhood of 85. So we're going to go ahead and say b equals 85. And now what I can do with the equation is say, if I fill m and b back into my equation, I get y equals 20.83x plus 85. And what I've done is I've been able to come up with an equation that demonstrates the pattern of this data. And what's really cool about this is now I can include any number for x. So any year that I would like to know data for, I can include it or put it into my equation and be able to figure that out. So once again, in this problem, we plotted the points, created the scatter plot. There was a line of best fit, and then we used 2 points from that line of best fit to come up with a slope, and we saw where the line crossed the y-axis to define or determine the y-intercept. So these are some of the things that you'll be working on for homework tonight. I hope this video helps. If you have any questions, talk to me in class tomorrow.